Hello rocket fans, and welcome back to the Copenhagen Suborbital's Rocket Shop, where we continue working on the world's only crewed, crowd-funded space rocket, Spica. Today is July 12th and it is time for some rocket updates.
Now, we've had quite a few requests after one of our last videos to talk more about Bianca's drone project as well as our rocket guidance, navigation and control software. So that's what Bianca is going to tell you about today, but before that, let's take a quick look at some of the interesting developments that were taking place in the Rocket Shop today.
But even before that, we would like to give a quick thank you to our today's sponsor, which is you. So the reason we're getting so close to reaching space on our Spica rocket is because all of our crowdfunding supporters. If you enjoy watching these insider videos on building a space program and you would like to become an even bigger part of it, you can help us out by going over to our website www.coppsub.com and becoming a supporter with a small monthly or one-time donation. We all do this for free in our spare time, so you'd be surprised how much every little bit helps, and thank you if you feel like what we do and share is interesting. So now we can get back to the main episode.
So here's a quick look at how John was aligning the last Spica propellant tank interface flanges before finishing the remaining welds on these bulkheads. We just can't thank all these clamps enough for their amazing help. Once these propellant tanks are done, they of course will be ready to fuel the Spica rocket engine. And if you're new to the channel, this is our upcoming 100 kilonewton or 10-ton thrust engine running on ethanol and liquid oxygen. And Rasmus and Thomas were working on its test hand design in SolidWorks. It is one of our next priorities, and we have already ordered some parts to begin the test hand production, with them hopefully arriving in the next few weeks. Then switching to the main subject of the day, with a bit of guidance from Martin, pun intended, Bianca made her first ever TIG welds when welding her drone rudders. In the meanwhile, Niels, our space medical doctor, helped by machining their support brackets. And from here on, let's just have Bianca do the rest of the talking.
So, hey Bianca, could you tell a little bit about what you're standing next to and why you're standing next to it?
I'm standing next to our drone prototype that is going to help us test some control algorithms. We want to be able to test some controllers for the new thrust vector control we're going to do through the gimbal engine for the new rocket, Spica. And so we want to be able to have some hardware platform to test on to start with, and then do the real thing. Because so far we were only able to properly test our controllers for Nexus 2 and Sapphire only on the moment of launch. And before that we did simulations, sure, but it's not exactly quite as realistic as seeing a controller tested on a hardware first. So we want to be able to test it safely. So we're just going to test it on this drone we've just built in the workshop. I'm building this as a part of my thesis. So far I've been testing what exactly challenges I can run into when doing the inertial navigation. The navigation part is generally the most, at least I found it the most challenging because of the orientations and the way the IMU is placed. So we needed to see what exactly type of challenges we run into doing inertial navigation. Now obviously the IMU that we're going to test, the IMU we're testing is different than the one we're going to use on the rocket. So the one we're testing here is a MEMS, whereas the one we're going to use on the rocket is going to be much better grade of precision. However, what I thought the most was that being able to run successfully algorithms on this one for sensor fusion and so forth would provide a very, very good experience for working for something much more precise. So this is the first iteration of the drone. It's going to be improved later, but right now what we want to do is to control it in 1D. So just one dimension, we just want to do the pitch for now. And if that goes successfully, add further on yaw, so in this direction, and then roll. But the pitch and the yaw are the ones that we are most concerned of, because the gimbal for Spica is going to use the pitch and the yaw angles. Primarily, the roll is going to be controlled by a different set of control systems. Over here, we just made for this purpose the rudder that is going to help control the flow of these propellers in one dimension. And then this one is tied through some arms to a servo that I'm controlling through an Arduino. I wanted to have the Arduino placed on the drone itself, but from here I'm going to have a cable coming out that I'm going to visualize the data from in real time. I also have an IMU here, an inertial measurement unit, so that's a 9 degree of freedom accelerometer, gyroscope, magnetometer, which needed a lot of calibration. It still does every time I try it out. And then we have the propellers, and these are helicopter propellers, so they're very, very strong, very powerful. And we have to be careful every time we start them up. This would be the main parts that I'm mostly working with. The rest is the frame that was built by us in here to be a bit more stable. It's going to be reinforced a little bit because it still wobbles slightly, and this could throw off the results of the test when I start the controller. These were frames that were CNC plasma cutted in our workshop from aluminum to be a bit more light. This one, however, is steel because it had to be welded on. It was a bit difficult to weld with the aluminum, so we just went for the steel. These would be the main parts, and what I'm mostly interested in is controlling the flow that comes from these propellers down to this rudder, for now. Later on, we want to construct something that would direct the flow into direction, so pitch and yaw. But for now, it's going to be just pitch. And to start with, this is going to be put in a frame that will allow for the testing of the pitch. So that's what we have for the most part. Now that I have this, I am working on tuning the controller. Right now it has a PID. It has a proportional integral derivative controller, but it's not tuned. And I want to tune it model-based. I want to go a bit more in depth into the control part, which I haven't had the chance to do so far because I've spent most of the time on the navigation side. So on the localization, finding as good as possible position and orientation from the sensor that we have. So now I want to look a bit more in depth into the control side. And now this means that I'm sitting at home with the simulation and building it as good as possible. And then I'm gonna try it out on the hardware over here. That's the plan. That's what I'm working on right now. This drone, for the start, it's not going to be left to fly on its own. With the current setup, it wouldn't even be possible because right now we're only controlling it in one dimension. And if I am to let it fly and then try to control the flow, it's gonna topple over. Super unstable. So right now we just want to set it up in a frame, hanging in there, and be sure that it can be properly controlled through this algorithm that I'm going to have, and with the setup. Once that starts and it's solid enough, we can take it over to leaving it fly freely. But the first stop is going to be in a frame that we're going to show. So this is the frame we want to use for testing the drone in the first place. We want to be able to test it safely without it taking off, without it just tangling in its own ropes and cables to begin with. So we want to constrain it to just being able to move in one plane of motion, so just the pitch. And so we're going to tie it up over here in a way that doesn't allow for any sort of sideways motion. We really don't want this to roll over. Once we are sure that the controller works and that it's giving us the performance that we want, which is a very fast and smooth control, so not very big movements, then we will be able to move to the next plane of motion and control it sideways and then control it maybe in the third as well. But for now, we want to put it up over here with some rope and see how it goes.
And that is all I had time to capture that day. So as always, thank you for watching and supporting. If you don't want to miss any of our future updates, make sure to subscribe and ring the bell so we can see you next time when we get one step closer to space.